In the second part of the video, I will be talking about the point slope method, and then we're gonna talk about some properties of parallel and perpendicular lines, and then applications. So previously we talked about what to do when we're given 2 points. Okay, so the question is, what if we are not given 2 points? In other words, if we only know 1 point that a line passes through, could we find the equation? The answer is no. We need more than that. What we need is we need to have a slope. So if we know 1 point and slope, then we can find the equation. The way we do that is we use this formula called the point slope formula, or point slope method. So the way it works is y minus y1 equals m times x minus x1, where we know that x1 comma y1 is a point on a line, and m represents the slope. So this is always called point slope form. So here's an example. Find the equation of the line that has a slope 3 and passes through the point 1 comma negative 2. What that means is my m in this case is 3. The point x1 comma y1 is negative 2. So I'm just going to use the point slope form, which looks like y minus y1 equals m times x minus x1. So then we're going to say y stays the same, and y1 given is negative 2 equals m, which is 3, x minus x1 is 1. So what we do is we kind of rewrite this a little bit, clean it up. So here plus, so it becomes minus, minus becomes plus, y plus 2, and then we'll distribute the 3 inside that parentheses so it'll look cleaner, 3x minus 3. And then you guys realize this does not look like mx plus b, so I'm gonna subtract 2 from the both sides, so y will be isolated, and that will result in something like 3x minus 3 minus 2, which is eventually y equals 3x minus 5. You guys realize now this looks like the point slope format, which is y equals mx plus b. So this is the equation of my line. So generally we recommend kind of cleaning up, combining like terms, and then making it look like y equals mx plus b. But again, it depends on the situation that we ask. Next up next thing we're going to talk about is parallel and perpendicular lines. So we know that 2 distinct non-vertical lines are parallel if and only if their slopes are equal. In other words, if 2 lines have the same slopes, m1 equals m2, they're always parallel. 2 non-vertical lines are perpendicular if and only if their slopes are negative reciprocal of each other. In other words, if m1 is the same thing as negative 1 times 1 over m2, or negative 1 over m2. So if this situation is met, then we can say that the lines are perpendicular. Alright, so then here's a problem. Find the slope-intercept form of the equation of the lines that pass through the point 2 comma negative 1 and are parallel to the given line 2x minus 3y equals 5 and perpendicular to the line 2x minus 3y comma 5. So we're gonna be able to find 2 equations that is going to be passing through 2 comma negative 1, and it's going to be parallel to this guy, and it's going to be perpendicular to this guy. Okay, 2 situations. All right, so step 1. So let's find the line that is parallel to the given line 2x minus 3y equals 5. So you guys realize 2x minus 3y equals 5. By simply looking at this line, could I tell the slope? I can't, right? The reason for that is it's not in y equals mx plus b format. It's a different format, right? So we call this format to be general format. I'll show you later on. But this is not mx plus b. So I will try to convert this into mx plus b so that I will know what the slope is. So I'm going to convert this guy. I'm going to isolate y. The way I'm going to isolate it is I'm going to do some algebra. So I'm going to move 2x to the right side, meaning I'll subtract 2x. So then that'll get me to negative 3y equals 5 minus 2x. I'm not done yet because there is still negative 3 for the y, because I want y to be isolated. For that reason, I'm going to divide everything by negative 3 just so y is just by itself. So then that'll get me to, this will simplify. So y equals 5 over negative 3 minus 2x over 3. And I'm going to simplify, clear this a little bit. I'm going to reorder them. So it'll be something like y equals negative 2, it's going to be negative 2 over negative 3. So for that reason, because we're dividing negative by negative, we'll have to have positive. So we're going to say positive 2 over 3 times x, or we can say 2x over 3, it'll be the same thing. 2 over 3a times x, and then minus 5 over 3. Okay, so then what that means is this guy is the y equals mx form, y equals mx plus b form of that given line. So could I tell the slope of this line then? Yes, so slope is whatever x is being multiplied, so m equals 2 over 3. So what I did is basically using the given line, I found the slope of that given line, 2 over 3. So what I'm trying to do here is that because the equation of the line that I'm looking for is not given yet, we're using the line that is parallel to that to determine its slope. So that means is that 2 over 3 then must be the slope of the line that I'm trying to find. Okay? All right, so then next up is then the line that is parallel to that is gonna have the same slope, 2 over 3. So are we done yet? Kind of. So next what we're gonna do is now we're gonna find the line that passing through that given point in the first place, and then parallel to my line, to my given equation. So the way I do that is I use the point slope format because I know point and I know the slope. So then point given is x1, y1. The slope here is 2 over 3. So then I'll say y minus y1 equals m x minus x1. So replace y1 with negative 1. Slope with 2 over 3. X minus x1 is 2. Simplify this a little bit. Y plus 1 equals 2/3 x minus 2 over 3 times 2 will be 4 over 3. And isolate the y, so subtract 1 from both sides. So you get y equals 2/3 of x minus 4 over 3 minus 1. And I think that'll lead us to y equals 2/3 x minus 7 over 3. Okay, so this is the equation that is parallel to that other equation. So this is parallel to this other equation. And then in the graph that I gave you over here, you guys realize that this red line and the green line seems to be parallel. You guys realize they have the same slope. Oops, where is it? Well, this is the slope here is not explicit, but I mean we know that this line is the same thing as what I did here because I converted that line into y equals 2/3 x minus 5 over 3. So you guys realize these two lines have the same slope, but they have different y-intercept. So parallel lines always have the same slope, but different y-intercept. All right, so next we're gonna do is we're gonna find the line that passes through that given point, but perpendicular to this guy. So this guy has the slope equal to first, that's what we know. And then what we know about perpendicular lines is that their slopes are reciprocal. And so the way they're negative reciprocals of each other, what that means is the slope of one has to be the negative 1 over m2. So if we know this guy has 2/3, then the slope of the other one could be determined by using this formula. So we're going to say then the slope of the other one, m1, must be negative 1 over m2, which is what we know, 2/3. So then this guy must have the slope being negative 1 over 2/3, which is actually convert that. So negative 1 times 3 over 2, which is negative 2 over 2. So slope of this line that we're looking for is going to be negative 3 over 2. And because it passes through that point 2 comma negative 1, then we can again apply the slope point slope format. Point slope form. So we're going to say y minus y1 equals m times x minus x1. Do the same work. So y minus minus 1. Slope this time is negative 3 over 2 times x minus x1. Then we're going to say y plus 1 equals negative 3 over 2x. Distribute that. Oops, I forgot to replace x1. My x1 is 2. So distribute negative 2/3. You get negative 2 over 2 times negative 2, which I think is, because these will cancel out, you'll just get 3. Okay, and then I'm going to subtract 1 from both sides because I'm going to isolate y, so I get y equals negative 2 over 2x, 3 minus 1, which will result in 2. So this is the line that is perpendicular to the given line 2/3 x minus 5 over 3. When we go back to that given graph, you guys realize I'm going to mark it with purple. This guy, oops, so this guy is perpendicular to this given line at that point because it has the slope. You guys realize slope here is negative 3 over 2, which is the negative reciprocal of what we initially had for the other guys, because the other guys has the slope 2/3, but this one has negative 3 over 2. All right, so that concludes this example. So lastly, we're going to talk about an application problem. So the problem goes following: the sales for Best Buy were approximately 49.7 billion in 2009 and 50.3 billion in 2010. Using only this information, write a linear equation that projects the sale in terms of the year, then project the sales in 2013. So what we need to do is come up with an equation that represents sales, and we're going to use this equation to project sales in 2013, because all we know is the sales in 2009 and sales in 2010. So we have like two kind of data points, two reference points. And so what we will do is using just the two, we will be able to just the two data points, we will be able to find an equation because we have the tools for that. We just learned that how to find equations, how to find slopes, and that'll be extremely useful. So then we're gonna say let t equals 9 represents 2009. Then the two given values represented by the data are 9 comma 49.7, because this will always be like kind of x and y, and then 10 comma 50.3. So 10 is representing 2010, And so then the slope of the line is using the equation y2 minus y1. So we do y2 minus y1 over x2 minus x1. So here we were able to find the slope, which will get you 0.6. So using the point slope method, we will be able to come up with an equation because we know a point and we know the slope. So y minus y1 equals m times x minus x1. So y minus 49 over 7 equals 0.6 times t over t minus 9. And this will get you y equals 0.6t plus 44.3. All right. So then this is what we use to project sales. So this will use this to project sales. So next thing we're gonna do is we're gonna actually project the sales for 2013. So for that we use the t being 13 because 2000 is kind of my reference point, and then I'm gonna use t equals 13. So y equals 0.6 times 13 plus 44.3. So I'm gonna replace x with that because this is almost like an x value. And then using that x value, I'm able to find the y, which is 52.1 billion. So according to our analysis, the projected sales will be 52.1 billion when it is 2013. Okay? So again, linear equations are extremely useful when it comes to application problems like this. This will be very useful in the fields of finance, economy, and things like that. But again, this is not the only field that linear equations are useful. There will be some other contexts as well. The prediction method that we illustrated in example is what we call linear extrapolation. So what we do is we basically estimated a point using the two given points, right? So that's extrapolation. There's two types. So whenever we do estimate a point that lies that does not lie between the given two, so let's say you have given this one, but then you project another point, estimated point. So this is what we call extrapolation. But if you project an inner point, so like say you're given this point, and then you project this middle point, then what we call this situation to be linear interpolation. So in the example we did, you guys realize we were given 9, 49.7, 10, 50.3, but what we did is we estimated this other point, which is not, it doesn't lie between those two. So this is linear extrapolation. This is what we call linear extrapolation. All right, so now we're gonna kind of summarize our knowledge in general. So this is something I mentioned earlier. Any line that has an equation that can be written in ax plus by plus c equals 0 is what we call the general form. Okay, so far we learned y equals mx plus b, right? So this is what we call point slope intercept. But in some cases, you will see equations that looks like ax plus by plus c equals 0. So you guys realize by just modifying equations, you can have different types of forms. So we have different names for these. So the point is that any line can be written as ax plus b plus c equals 0, regardless of whether it is vertical, horizontal, or neither. Mathematicians like one-size-fits-all formula that covers all possibilities. So this basically covers all possibilities. So it's like a very general equation, very general. So next up in the list, we summarize equations of lines. So general form we just illustrated is always ax plus by plus c equals 0, where I need to mention a, b, and c are constant numbers. constant numbers, and x comma y are variables. So you need to differentiate that a, b, c are constant numbers based on given situations, and x and y are variables. We learned that vertical lines always look like x minus a, horizontal lines always y equals b, slope-intercept form is always y equals mx plus b, point slope is y minus y1 equals m times x minus x1, 2-point form. This is basically a modified version of this previous one. All you do is to replace m with this guy, because you first find the slope using 2 points, and then you replace it in the point slope format. So yeah, that's gonna be all for linear equations.